So nanotechnology is changing how we can make solar cells. And the next generation of solar panels are these lightweight, flexible, thin film solar panels that are easier to produce and easier to install. Now, they work exactly the same way as a traditional solar panel, but they have a different semiconducting material. And the way they're fabricated is different. And that's what has the potential to make it so much less expensive and easier to produce. You see, it's kind of like a printing process, much like an inkjet printer works. You start with an ink that has tiny semiconducting nanoparticles inside, and that ink goes into a printing press, and it's just sprayed or printed onto these foil or plastic sheets. And you're able to print rolls of it. I have a video of that process at a company called NanoSolar out in California. You can see the nanoparticle ink coming into the printing press. It's being sprayed onto these foil sheets. They're able to make a mile-long roll, or 50,000 solar cells, in just a couple of hours. This process promises to make them much cheaper and obviously much easier to produce. Now, it's not just NanoSolar that's doing this. There's a company right here in our own backyard up in Lowell, Massachusetts, called Konarka. And Konarka is making solar cells a very similar way. I have an example of their flexible plastic solar panel called Power Plastic. Now, what's interesting is Konarka is not just looking at collecting solar energy from roofs. They think there are so many other places that we can collect solar energy. Imagine a messenger bag that would charge your laptop when you're walking around. They're working on a transparent thin film solar cell, that picture on the right. Now, a transparent thin film cell could be incorporated into windows. So in the future, office buildings like this could have those transparent thin films in the windows. Imagine how much solar energy could be collected by a building that size. More than enough to power every office in the building and much of the surrounding neighborhood. So it's a very exciting way that we could use nanotechnology to collect more solar energy. Now, there are other research projects that are kind of interesting, sound a little bit like science fiction, but I promise you it's not. What about solar paint? There are a number of universities working on this right now. Now, the idea is you're not going to put a solar panel on your roof. You would just paint your roof. Now, of course, it's a little bit more complicated than that. You need some kind of conducting layer on your roof that's going to collect the electrons. You, of course, need wires that are going to channel that electricity into your home. But on top of that, you're not going to put a silicon panel. You're going to paint this dark, sunlight-absorbing paint. And inside that paint are these tiny semiconducting nanoparticles. But it works the same way. Sunlight hits those nanoparticles, knocks electrons loose, creating an electric current. And because we're just talking about paint, it has the potential to be very inexpensive and very easy to install in a lot of different locations. Again, a very exciting way we could use nanotechnology to harness a lot of energy. Now, there's another way it can help us, and it has to do with how we distribute energy. There is a problem with our transmission wires, and a lot of people don't really realize what that problem is. So I have a demonstration to show you. I have a hand crank generator hooked up to a little light bulb, and I have copper wire, much like our transmission wires use. Now, this turns movement into electricity to light this light bulb. Now, for this demonstration, I need a volunteer from the audience. Can I get a hand? Would you please help me? Thank you. And what's your name? Ben, thank you for helping me, Ben. Would you stand right where I was standing? And would you give that a good crank and see if you can get the light bulb going? Excellent, you can stop. So Ben and I, we're gonna have a competition. I have an identical hand crank generator over here, and we have identical light bulbs. But the difference is that Ben's circuit has about 1 foot of copper wire, and I have these 2 spools. I have 250 extra feet of copper wire in my circuit. Now, you guys as the audience, I'd like you to judge whose light bulb gets the brightest. Is it mine or is it Ben's? Are you ready? Are you ready? On your mark, get set, go. Can you tell whose light bulb is brighter? Excellent, it was definitely Ben. Let's give him a round of applause. Thank you, Ben. So why do you think Ben was able to get his light bulb so much brighter than mine? It has to do with the distance. Ben's electricity only had to travel through 1 foot of copper wire, and copper is an imperfect conductor. When we move electricity through copper wires, we lose a little bit due to resistance. And the further we move it, the more electricity we're going to lose. And that was a huge problem for me with 250 extra feet. And that's an even bigger problem with miles and miles of transmission lines. In the United States, we lose 10% of our electricity just due to the resistance in our transmission wires. So having better transmission wires would instantly translate into huge energy savings. Now, there's a new material that could help us save that energy. And that material is called a carbon nanotube. Now, this is a gigantic model of a carbon nanotube. The real ones are tiny. They're only 1 or 2 nanometers across. In other words, if I took one human hair, I could fit about 50,000 carbon nanotubes across that distance. So the real ones are tiny, but this shows you their shape and their structure. They're long, skinny tubes made entirely of these 6-sided, hexagon-shaped carbon rings. Now, at the nanoscale, these carbon nanotubes have incredible properties. They are incredibly strong, many times stronger than steel. They're lightweight, they're flexible, and they're excellent electrical conductors. We can move electricity through carbon nanotubes very quickly, controlling it with very little power, and we lose almost no energy due to resistance. So in the future, as our grid gets older and needs to be replaced, if we replace them with carbon nanotube transmission lines, we could transmit our electricity much more efficiently. Now, the challenge here is this is a relatively new material. We just discovered it in the mid-90s. So we're not that good at mass producing these yet, but we're getting better all the time. And in the future, the next couple of decades, we could very well see carbon nanotube transmission lines. Now, there's one final way that nanotechnology can help our energy. And I want you to think about lighting. A lot of people are surprised to learn that fully 20% of our electricity just goes to provide lighting. So using more efficient lighting also really quickly translates into good energy savings. Now, most of you are familiar with incandescent light bulbs. These actually use much more energy to generate heat than they use to generate light. And you've probably felt that if ever you tried to change one of these with a bare hand when it's still pretty hot. So an even better option are compact fluorescent bulbs. Now, these are gaining in popularity. They use much less energy. They don't waste as much energy on heat. But a lot of people are turned off by the really harsh, sterile white light they produce. And they also contain mercury, which is a pollutant. So an even better option than CFLs are LED bulbs, and I have an example right here. They come in many different kind of shapes and sizes. Now, LEDs are not a new technology. They have been around for a little while, but they weren't good enough to really provide a lot of indoor lighting until recently. A lot of lighting companies are using nanotechnology research to improve LED bulbs. And they're using them to improve them in so many ways, to make them easier to produce, to make them more energy efficient, to produce a brighter light, to produce a nicer light color quality. So these advances are going to make LEDs much more prominent. Right now, they make a small percentage of the lighting market, but in the next decade or so, all the lighting companies expect these to become by far and away where most of our lighting comes from, these super energy efficient LED bulbs. So those are a variety of ways that nanotechnology can help us with some of our energy problems. But whether or not these technologies succeed is a question of investment. This picture shows you a solar farm in Germany. And Germany has one of the most advanced solar programs in the entire world. And that's because the German government has made a huge investment, not just in solar research, but also in getting its citizens and industries to use solar technology. Now, they are shooting to be at 30% of their energy from renewables like solar by the year 2020. The United States is lagging quite a bit behind. We have a long way to go to catch up. But nanotechnology has shown us some great ways that we can do that. But we must decide to pursue these technologies if we want to see them develop. I hope you learned a little bit about energy and nanotechnology today. If you'd like to hear more about some of the applications I spoke about, here are a few websites you might be interested in. One is called understandingnano.com. It talks a lot about the various ways nanotechnology can help with our energy. A second is a link to a great PBS Nova documentary called Saved by the Sun that talks a lot about the future potential for solar energy in the United States. And finally, a link to EnergyStar.gov, which has some information about tax credits if you're interested in making your own home more energy efficient. I'm happy to answer any questions. You can come on up after the show. Otherwise, I just hope you enjoy the rest of your day here at the museum. Thank you very much.